Hello students, we are working in Chapter 6, the last chapter in this video course, and right now we're going to be working again in Section 6.2 today. We started it yesterday, but we're going to work on a couple examples in that section again today. So let's take a look now at Section 6.2, which is the multiplication and division of rational expressions. Okay. Yesterday we began looking at this section, and we're going to continue with two examples today. The key thing I want you to remember that whenever you multiply or divide rational expressions, first you treat them like fractions, so you multiply or divide as you would fractions. But secondly, and most importantly, you always want to factor first before you do any multiplication and division. And so actually, let me highlight that. You always want to factor first whenever you're doing these problems. And I'm going to write this in a color so that you make sure you remind yourself. Always factor first. Okay, so let's take a look at two examples then. Let's look at example number 1. I'm going to divide two rational expressions. Let's take x squared plus 6x plus 9 over x squared minus 25, and let's divide this by the rational expression x minus 3 over x plus 5. Okay, so as I mentioned, we're going to treat this just like fractions when we do the division, but our first step is always to factor. So let's do that first. Let's factor each of these two polynomials here. X squared plus 6x plus 9. This factors as x plus 3 times x plus 3. Okay? X plus 3 times x plus 3. And x squared minus 25, that's a difference of squares, that factors as x plus 5 times x minus 5. So that first rational expression is simply the factors x plus 3 over x plus 3 times x plus 5, or divided by x plus 5 times x minus 5. Okay. Now what are we doing? We're dividing that by the rational expression x minus 3 over x plus 5. Okay, so now what do we do before you can do any canceling or multiplying? The first thing you want to do is convert this division to a multiplication problem by inverting the second fraction. So we're going to invert the second fraction, and so what you're going to get is you're going to get x plus 3 times x plus 3 over x plus 5 times x minus 5. You leave your first fraction alone, but you're going to convert the second one. So now you flip the second one and make that times, actually let's put a dot there, times x plus 5 over x minus 3. So I've simply converted this expression here to this. And now, cancel. Is there anything that we can cancel? Let's see. Well, you can cancel an x plus 5. Is there anything else that can be canceled? Well, you might be tempted to say x minus 3 can cancel, but it can't because this is x plus 3. There's nothing else that cancels here, so we just have to multiply now. X plus 3 times x plus 3 times 1 is just x plus 3 times x plus 3. And in the denominator, you have 1 times x minus 5 times x minus 3, which is just x minus 5 times x minus 3. And again, nothing will cancel. So you can either leave your answer just like this, or you can FOIL it or multiply it out. Rewrite this as a polynomial, x squared plus 6x plus 9, and rewrite the bottom as a polynomial, which is going to be x squared minus 8x plus 15. And you could also leave your answer that way. Okay? They are equivalent. Either way is fine as far as answers go. Okay, so the key is we always took our expression and factored first. Let's take a look at one more example before we move on to the next section. Let's look at 2 over 3x plus 3 times x plus 1 over x plus 8. So I have 2 over 3x plus 3 times x plus 1 over x plus 8. Factor first. You can't factor here, but you can factor here, so let's factor that. 3 times x plus 3 can be factored as 3 times the quantity x plus 1. Over here, neither of those two polynomials can be factored, so we'll still have x plus 1 over x plus 8. Let's cancel. Because this is a strict multiplication, I don't have to flip, so I'll just cancel. And in fact, x plus 1, notice, cancels. And nothing else will cancel. You can't cancel the 2 with x plus 8. You can't cancel the 2 with the 3. And so your final result, when you multiply across, you'll have 2 times 1, which equals 2, and 3 times 1, which is just 3, times x plus 8. So you'll just have 3 times x plus 8, and you can leave your answer like that. Or if you want, you can multiply out that bottom. When you multiply out that bottom, you get 3x plus 24. And again, either of those answers are acceptable because they're the same thing. One is just factored and one is not. So, until next time, practice, and then I will see you with section 6.4. Bye.